Station, this is Houston. Are you ready for the event?
Hello, Houston. This is Station. We are ready for the event.
Houston, ACR, this is Mission Control. Please call Space Station for a voice check.
Station, this is Houston, ACR. How do you hear me?
Houston, ACR. Hello, loud and clear.
Hi, everyone. I'm astronaut Nick Hague, and I want to welcome all those who are tuning in today, especially our educators from across the country. It's Teacher Appreciation Week, and as the son of 2 teachers, I send a special thank you as you continue to inspire and engage students during this challenging time. I think I can speak for all the parents out there when I say we truly appreciate you. Now, are you in for a real treat? As my teammate and friend, astronaut Chris Cassidy, will be answering your questions live from the space station, 250 miles above the Earth. Are you ready to learn? Let's get to it.
Hi, my name is Nathan Tubbs, and I'm a 7th grade science teacher at PSIS 30, the Mary White Ovington School in Brooklyn, New York. My students and I would like to know if you could give a specific example of how your training as a naval officer helped you to solve a problem faced by you and your crewmates.
Nathan, that's a wonderful question. Training as a military officer or military person in general involves thinking critically, using all the resources available to you, and really thinking 3 levels into a situation before you get to the situation, so you may have already thought of some variations of the problem that's been dealt with you. That's also the method of training that we use at NASA. So it was just reinforced when I arrived here and began training at NASA. A specific example that comes to mind is on my first or second spacewalk. I can't remember exactly which one. My friend and colleague Tom Marshburn and I were outside out at the far end of the space station on the port side changing some batteries, and they were being very stubborn, and the bolts would not want to work, and the 2 of us had to think together and work in tandem to apply every bit of force that the tools we had could give to the bolts and our physical strength to get them done, but not only on that spacewalk, but on time, because it was a ripple effect for the rest of the space station. So I'm not doing a super great job of describing the situation at the moment, but in the heat of the battle, Tom and I were using all of our mental resources together and with the ground to come up with a solution to that problem. And that is the kind of situational awareness and critical thinking that was rooted in my military career and reinforced when I got to NASA.
Hi, my name is Bev Barikian, and I'm a 7th and 8th grade integrated science teacher from Lexington Junior High School, and that's in Cypress, California. And my question for you is, how does the work aboard station, including those long-term experiments, change with crew rotations?
Well, that's an interesting question. There's many experiments going on the station, and we're changing, as you know, crews every 6 months, and some when we're on a normal cycle, we're changing every in between in there as well, every 3 months. So it happens all the time, and it's the ground team that's really managing all of those science experiments. We are knowledgeable about them, but really the critical turnover from crew to crew is how you operate the device on board the space station and where particular pieces of equipment are stowed. Many of these experiments have very unique tooling or unique pieces of gear that without it, the experiment can't function. So knowing how to manipulate those mechanisms and where to store them so you're not hunting all over the place trying to find something that you think is lost, that's the kind of turnover that we do crew to crew. The big picture managing of all of those experiments, again, is done by the true experts on the ground.
Hi, I'm Becky Fritchie from Spanish Lake Primary in Louisiana. My question is, since the quarantine has caused less emissions in the Earth, can a difference be seen from the ISS? Are there different cloud formations or colorations that you guys notice on your trips around the Earth? Thanks!
That's a popular question. We've been asked a few times, and I really have been trying with some diligence to see if there's anything perceivable that I can notice with my eye. And unfortunately, there's nothing in the atmosphere, nothing in the cloud formations that would give me a sense that there's a pattern to it or to compare to previous missions that I've been here. The only thing that I can say I notice are less airplane contrails zigzagging across the country and across other continents as well. It seems to me that airplane activity is less, and that's something that we can see, particularly in the busy times of the day when you know there's a lot of business commuters normally going back and forth in the United States is where I can speak with some knowledge. But you don't see that quite so much these days. The rest of it, though, we have serious science equipment and experiments on the outside of the space station that are doing just that, looking for the technical answer to your question.
Hi, my name is Amanda Blau, and I'm a teacher at Corpus Christi Catholic School in Chambersburg, Pennsylvania. And my question is, how do you prepare both mentally and physically for emergency situations such as the one that happened in your spacewalk with Luca Parmitano during Expedition 35?
Well, one thing we do really, really well at NASA, I think, is prepare for contingencies and emergencies. We spend an awful lot of time learning different things that we think could go wrong. And that happens in the pool where we train for spacewalks as well. We had never practiced a scenario where somebody would have water in their helmet. We just didn't think it was something that was possible. But we always practice getting back to the airlock quickly and safely, helping one another get back there, or just doing that in a way that's expeditious. And that's routine in our astronaut training. So it's ingrained in all of us. So I wouldn't say that there was anything specific about that particular spacewalk that was different from that training. We knew we had to get back quickly. And we just did just that. And my hat really goes off to Luca. He's the one that had the water in his helmet and was able to find his way back to the airlock. I had one job and one job only, and that was to close the hatch so we could start pushing air back into the airlock and then get his helmet off. But we worked together to make all that happen, and it's really, really grounded in the extensive emergency training that we have on the ground before we get to space.
Hi, my name is Jessica Strauss, and I'm a teacher at Mabry Elementary in Tampa, Florida. My question is, with the world battling to understand COVID-19, what kind of research is conducted on the International Space Station that furthers our understanding of viruses and vaccines?
Wow, gosh, you actually have me stumped on any specific answer. I don't know off the top of my head to give you the name of the experiment. And in certain times, we can access the internet up here. It's not as awesome as having the internet right at your desk. So you and I can do that together. And you gave me a good homework assignment is to look up and see. I'm probably, as soon as this conference is over, I'm probably going to get 3 or 4 emails like, Chris, you should have talked about this and this. But I'm interested to know that answer as well. Thank you for that question.
Hi, I'm Katrina Roddenberry, and I'm a teacher at Wakulla Middle School in Florida. My question is, are there any methods of problem solving on space station that are different from those that you used in your career as a Navy SEAL?
Well, SEAL team training is technical in its own way. Astronaut training is technical in its own way, but a common baseline between both careers, and I touched on this a little bit in an earlier question, is that kind of overall awareness of what's going on around you, the ability to understand what the mission is and what the risks are to accomplish the mission, and know when you can push the risks a little bit and when it's time to back off and throttle back away because the risk isn't worth taking to try to accomplish the mission. And so what are they different? No, it's hard for me to find a difference in there. The real, with any complicated operational job, it's all about balancing mission success versus risk. And that, I think, is a common thread. So I don't really have a difference in philosophy for you, other than the true technical nature of being a SEAL is completely different than the technical nature of being an astronaut.
You and the ISS crew are isolated on station. However, you receive guidance and assistance remotely from Mission Control. As our students are now isolated and receiving their education and guidance remotely, what advice would you give teachers to best support them?
Well, that's a loaded question since Mission Control is listening, but I will tell you that it's tough to find the balance between presenting help when is needed, and then but not being there when you need it, and not being overstepping your bounds. Because on the space station, just to be quite honest, a lot of times we know what a particular activity is, and maybe we're getting more and more words that are saying the same things that we know. It doesn't happen very often, but it does. And there are other times where we need a little bit more information. As a matter of fact, today I was working on a stubborn piece of equipment, and together with the ground we were trying to solve the mechanism, and all of us understanding what was happening with these rotating pieces. And so the real balancing act is being there, available, but know that the student knows that you're accessible and that they feel comfortable reaching out. And that's a challenge, and I think that's what makes educators amazing, and it's why it's difficult, I think, to be a teacher of your own kids. Because it's a different relationship at home at the dinner table than is required in the classroom. And I think there's a lot of families out there appreciating homeschooled families even more now. But that's a great question, and good luck to everybody. I know it's a really unique time in the education world right now, and people are sorting through just how best to proceed. So thank you very much to all of you for doing that.
I'm Becky Busby, a teacher at Frank Long Elementary in Georgia. The Apollo 8 Earthrise photograph gave us a new perspective of Earth as well as space. What image would you select to represent our future in space exploration?
Well, I think that's a fairly easy one. Our destination is Mars. And when you think of Mars, you think of there's many posters out there that, to me, I can picture it in my head. Astronauts in spacesuits walking around sort of the red planet there, and you see rovers and habitats in the foreground and the background, and a couple other astronauts in the vicinity. That's what I think of. I think of a small team of people with a very variety of backgrounds and nationalities, boots on the ground, exploring the planet, building infrastructure that will later on allow more and more people to explore there, vacation there, maybe install like a future movie that we see now. So that's what excites me, and the picture in my mind is exactly as I described: astronauts and rovers and habitats on the surface of Mars.
Hello, my name is Angela Case from Space Center Houston. I'm asking this question on behalf of Marcy Ward and Terry Minot from Alaska. Their question is, you work on a multitude of experiments on station. Do you know when you're working on a student experiment?
In fact, we do. Every week we get a science look ahead, and we get some information about what we're working on or things that we worked on in the past, and pretend possibly there's results that have come from something that we've been involved in. And if it is a student experiment, that we'll certainly know. For instance, on my last mission, Expedition 35 and 36, we worked with these small little roving satellites about the size of a soccer ball called spheres. And we were enabled with the communication, just like I'm talking to you, with the students in a large auditorium, and they had kind of a competition driving those things around. Those spheres we no longer use. They've been upgraded by my two friends Astro be here, and they're the kind of like generation 2 of the same concept. And later on in my mission, we will do the same thing. We'll interact with some students as they take part in some participation of that. Those are just 2 small examples, and there's many others.
Hi, my name is Courtney Black, and I'm a teacher at Allen Park Elementary School in Fort Myers, Florida. My students and I would like to know, looking forward to the Artemis missions, what skill or character trait do you believe will be most important for those individuals that are tasked with exploring and building a habitat on the moon?
Teamwork. You've got to be a good teammate, and you've got to know when to be a leader and when to be a follower, and it'll all pull together. The technical things we can train. NASA has an amazing ability to train people, both flight controllers, astronauts, and any other job that we have. So it's not a problem to learn the hard technical skills. It's that those soft skills that are of critical import as we bring people together to bond and form a team and collectively go conduct the mission. You also have to have some kind of mechanical aptitude to help fix things, because inevitably stuff is going to break. And as a crew, you need to be able to solve those problems, fix those things, and drive on. Teamwork.
Hi, my name is Lisa Stewart, and I am a teacher at Skipjaw Elementary School in Texas. My question is, in your career, whether it be with NASA or the military, what would you consider to be your most successful failure?
Yeah, that's a fun question for me to think about. Kind of go back in memory lane of different adventures and failures, successes. Probably the most recent one would come to mind, and that was with the spacewalk with Luca. It was mentioned a little bit earlier. We did not complete our tasks on that spacewalk. We did not get our activities done, but we were dealt a problem. We got back inside safely, and we could laugh about it once the helmet came off. But in terms of spacewalks, it was a failure. We did not complete what we set out to do. And the equipment was failed hard for about a year, maybe a little longer, until the big we, NASA, could sort it out, figure out why, and implement changes so that it wouldn't happen again. To include, we now have new procedures for spacewalks that tell us what to do if we have water in the helmet. It's something we take very, very seriously now. So in that failure of that spacewalk has come many improvements to safety of our operations here in space.
Hi, my name is Denise Duke, and I'm a teacher at Forest Lake Elementary in South Carolina. My question is, one of the investigations on the Expedition 63 mission is to test life support technologies that will be vital to deep space exploration. What technology will you test?
Well, clearly, life support is something you have to have. Just look at the name of the topic, and we have that on space station. We've been living on the space station for 20 years. We're in our 20th year, or at the end of this year will be our 20th year of manned presence on the International Space Station. From that, we have learned an awful lot about life support, removing carbon dioxide. At what levels do astronauts become not only uncomfortable but have headaches and can't function as clearly at different levels of carbon dioxide? We work with the Navy. Submarine data is very helpful for this as well. Dealing with water. As a matter of fact, in the last week, I've been dealing a lot with our water system, which includes urine. That is something that we're improved. I would say we're beyond testing. We're improving our ability to deal with this closed loop life support system where we can capture all the condensate from the atmosphere and the urine in the system and process it and deliver it back as drinking water. And if you really think about it, that's almost essential to having long-term presence off the planet Earth. It's something that is too logistically challenging to continue to supply all the needed water. I think I've drank 2 liters already today, and hopefully I can deliver some to that equation too later on.
On behalf of Space Center Houston, I'm delighted to thank Chris Cassidy, as well as everyone at NASA Johnson Space Center for all they are doing to further human space exploration. To Space Center Houston's international network of educators and every teacher committed to inspiring and educating our children, we thank you for your continued leadership and dedication in supporting today's youth.
Station, this is Houston ACR. That concludes our event as we count down to 20 continuous years of humans living and working on the International Space Station.
Thank you to all participants. Station, we are now resuming operational audio communications.